Hello guys, welcome back to my channel Algorithm Mind. In this channel, I teach programming skills in MATLAB, Python and hard programming. I also teach theoretical as well as practical programming skills in data science. So I request you to subscribe to my channel and hit that notification bell icon button. So I have been publishing a series of tutorial videos on MATLAB where I teach fundamentals of MATLAB programming. These tutorials are specifically designed for those people who are just beginner with programming and they want to learn how to code in MATLAB. So in today's tutorial, I'm going to go through a series of exercises where I will teach you about how to calculate the integral using MATLAB. And this will actually teach you how you can actually use functions in MATLAB, and then I'll also teach you how to plot a function of a symbolic representation or expression. So as you know, integration deals with two essentially different types of problem. In the first type, derivative of function is given and we want to find the function. Therefore, we basically reverse the process of differentiation. This reverse process is known as anti-differentiation or finding the primitive function or finding the indefinite integral. The second type of problem involves adding up a very large number of very small quantities, then taking a limit as size of quantities approaches zero. While the number of terms tend to infinity, this process leads to definition of definite integral. With that being said, let's move on and actually see how we can actually calculate the integral in MATLAB. So by definition, if the derivative of a function is f prime x, then we say that the indefinite integral, that is f prime x with respect to s, is f of x. That being said, so this is the basic definition of an integral. So in MATLAB, in order to calculate the integral, first of all, we have to define a symbolic variable. So this is how you can actually define a symbolic variable, syms x. Once you've done that, now in order to calculate the integral of 2x, what we are going to do, we are going to call the function int, which calculates the integral of a function or an expression, symbolic expression in MATLAB. So we are calling the function int, then we are passing input argument 2x, which is the expression of the symbolic variable x, which is 2x. Okay, so once we calculated that, we get an answer of x squared. So okay, so that's the integral of 2x. Now, what if we want to calculate the integral of 4x? We will pass the same input argument, let's say int, and then pass 4 steric x. So we get the integral to x squared. Okay. Now, that being said, in the same way, we can calculate the integral with a variable n in it. So in this case, we write int, and we first of all we have to define symbolic variable x and n and t. These are three symbolic variables that have been declared first. Once we done that, then we will write the MATLAB function int, and we will pass the input argument our symbolic expression, which is in our case is x power n. And once you calculate the integral, the result is quite interesting to see that such that we actually do get two values of integral. That is, by definition, we will get log of x and xn plus 1 upon n plus 1, which based on whether the n is positive or negative. If the n is negative, then we will have log of x. If n is not n is not equal to 1, then we get this integral. And the same way, we can calculate the integral of sine, cosine as well. So for example, I have declared a symbolic expression f is equal to sine nt. So there are two symbolic variables in the sine, and when we calculate the integral, it will calculate the integral, and the answer will be when we pass this expression to int function, integral function of MATLAB, and we will get minus cos nt upon n. In the same way, you can calculate multiple integrations of multiple symbolic expressions, so which we have done in that file. I will share the live scripts for you so you can actually exercise this concept as well. And Yes, we can actually calculate the integration of polynomial terms as well, polynomial equation of polynomial degree. And okay, now let's move on to actually finding the definite integral using MATLAB. By definition, definite integral is basically the limit of a sum. The integer command can be used for definite integration by passing the limits over which you want to calculate the integral. Okay, so basically you have to actually give the limits of the integral along with the function or symbolic expression. So now we are going to pass three input argument to this function int. The first input argument will be the symbolic expression, and the second and the third input argument will be the limit of the integration one for whatever the value you want to be. Okay, so in this case I have a symbolic expression just only x, and my limits are 4 and 9. What if I change these values? Let's say I want to change this value to 10. Now my limits are 4 to 10. Now I get a different value. So this is how you can actually calculate the integral, definite integral. That means it. Now you also know that the integral can also be used to calculate the area under the curve. So this is exactly what we have done here. So for example, we have an expression f is equal to x power 3 minus 2x plus 5. So this is an symbolic expression and we are calculating integer of this symbolic expression, and we are taking the limits 1 to 2, and we are storing that value in a. After we store that value in a, we are actually just using display function to display the value, and we are converting that value. Please remember that whatever the integer might be calculated here, for example here, is of the type symbolic. So in order to convert that symbolic into numeric value, you have to use this function double here. That's what we have done here. That's so once we run this block of code for you, you will see that we get a value of area. In the same way, we calculate the area here. We have a symbolic expression. We calculate the integral with respect to some limits, and then we display the value using this function in MATLAB and converted that value into double type by using double function here. And then finally, we are using easy plot function, and this takes two input argument. The first input argument is actually the symbolic expression, which is x power 2 cos x, and the second input argument is actually the value of x-axis. Okay, so it starts from -4 and it goes to 9, and it plots the value of this function with respect to the -4 to 9, and you can see the function plot using this easy plot function. This is quite a handy tool when you actually want to visualize your expressions. In the same way, let's move on and discuss this P here is actually a matrix, and it has elements. How many elements? It has 6 elements. So basically it represents the coefficients of polynomial equation. Okay, so it represents the coefficients of polynomial equation, and using poly int, we actually integrating that equation that has a polynomial these. Okay, so it will have like 0, 1, 2, 3, 4, 5. So it will be 4x5 plus 0x4 minus 2x3 and so on. So by using poly int, we are able to calculate the integral of this polynomial degree equation. So that's how you can do it. That's it for now. I hope this tutorial has been helpful, so that you are able to grasp how you actually can use functions in MATLAB, or how to plot function or symbol, how to deal with symbolic calculations. So in the upcoming videos, I am going to teach you about how you can actually write functions in MATLAB. I will teach you about conditional statement, as well as I will teach you about plotting and using loops in MATLAB. So it will be a highly resourceful video. I suggest you subscribe to my channel and hit the notification bell icon button, so you can get the notification as soon as I publish this video. Thank you for watching my video. I will catch you soon in the next video.